Hi, I'm Enol Balado, and this is my demo reel, where I showcase my workflow for implementing audio in Unity using Wwise integration. For this project, I've used the first-person sample project from Unity. This video is divided into 3 sections. First, I will present a footstep system with material-based switching between dirt and concrete. Then, I will show a rubber system that adapts to the size of the space. And finally, I will demonstrate an attenuation and occlusion system to simulate more realistic sound behavior within the engine. The footstep system is built using 2 random containers in Wwise. Each container includes 10 samples, one set for the dirt and another for concrete. Parameters such as speed and timing are slightly randomized to introduce variation and avoid repetition. For the Unity implementation, I modified the first-person controller script to trigger Wwise footstep events at a controlled rate. Since this is a first-person perspective and we don't see the character's feet, the step frequency is defined manually in the script to achieve a natural rhythm. To handle surface changes, I created transition zones using box colliders placed at the boundary between materials. By combining the AK switch and AK trigger enter component, the system detects when the player crosses these zones and updates the surface type accordingly, ensuring the correct footstep sound is played. So let's hear it. For Reverb, I set up 3 box colliders that define the areas where different acoustic behaviors occur. Using game-defined auxiliary sense and the AkEnvironment component, I control how specific sounds such as footsteps are sent to reverb effects. As the player moves between spaces such as the main hole and the container, the reverb adapts to reflect the acoustic properties of each environment, enhancing spatial realism. Additionally, for the container space, I added a subtle flanger effect to emphasize early reflections, helping to convey the tight and reflective nature of that environment. Finally, I implemented a looping bird sound positioned in a nest at the top of a tree. This setup demonstrates 2 key behaviors. First, distance-based attenuation. As the player moves away, the sounds decrease in volume and applies a low-pass filter, simulating how high frequencies are lost over distance. This is controlled through Wwise attenuation settings. Second, obstruction and occlusion. Using the AK emitter obstruction occlusion component, the system detects obstacles between the emitter, the bird's nest, and the listeners, the player. When an obstruction is present, the sound is attenuated and filtered to simulate how material affects sound propagation. To visualize this process, I developed a custom debug tool called Wwise Occlusion Cinematic, which renders rays between the emitter and the listener. These rays illustrate how sound paths are blocked or partially obstructed, making the underlying system easier to understand in real time. Thanks for watching.